Bismillah. Right, good morning class. So today we're wrapping up your Euclidean geometry. You had to do the revision exercise. At this point we have completed up until 9.8. The revision exercise was the handy assignment. Okay. So out of the revision exercise on page 235, any problems on number 1? No. Number 2? No. 3? Anybody have a problem number 3? Yes, okay. How was the exam today? The test? Easy. Sorry? Not enough time. Who managed to finish? That people finish. Sorry? It's fine. As long as they finish, it's fine. Number 4? Number 4? Yes. So that means to say you must prepare yourself well for the upcoming exam. Eh?
Yes, sir.
But at least you got the wake up call now.
Yes, definitely.
Number 5? 6? 6? Okay. Number 8?
Yes, yes.
So 7 is not 7. This is the issue. Number 8. Number 9? Number 10? Is it number 10?
Yes, sir.
Waalaikumsalam meneer. Hoe gaan het? Need a refill kan hulle men. Die bottles is op laag gedrink. Number 10, 11, 12, 13. Yes. Just refer 11D to the written memo. Okay. I don't even think we'll get through all of this, but let's try. No, it's not so many. Alright, so this is the revision exercise. Revision exercise on page 325. Right. So we are given quadrilateral ABCD with AB equal to AD equals AD. Yeah, AD is equal to AB, which means to say that this is an X here. Then we are told that those two lengths are equal, so that's going to be 2X. Okay? So this is going to be 180 minus 4x. There's going to be 180 minus 2x. Is that correct? Alright. Prove that ABCD is a cyclic quadrilateral. And there we go. Opposite sides are supplementary. Can you see that? But how do we lay that out? Okay, so we firstly say that B1 is equal to X. Why? What's going on? Angles opposite equal sides. So we say then that angle A is going to be 180 minus 2x. Why? Sum of triangles, and it's triangle ABD. So I just need this angle here. So angle C is 2x. Why? Again, angles opposite equal sides. So now we state the obvious. We say since angle A plus angle C is equal to 180 plus 180 minus 2x, which is equal to, so actually 2x plus 180 minus 2x, which gives you 180. Therefore, ABCD is a cyclic quad. Why? Because we got opposite angles supplementary. Okay, opposite angles adds up to 180, therefore it has to be a cyclic quad. Let's carry on. Number 4. We are told that O is the center of the circle with diameter AB. Okay, so that's your diameter. Then we are told O is your center as well, so all of those lengths are equal. Okay. Then we are told that CPD is perpendicular to AB, which means to say now that CP is equal to PD. Why is that the case? Perpendicular from center to chord by sixth chord. Okay? Then we are told that ED and AB intersect at F, which is this point here. CO is drawn, B2 is X, prove that. B1 is equal to B2. So to prove that B1 is equal to B2, B2, I think we're going to go with congruency. We'd have to go with congruency. So A, so we start off in triangle CPB and triangle DPB. What can we say? We're going to say that CP is equal to PD. Why? Because they're perpendicular from center to chord. Perpendicular from center to chord by sixth chord. P1 is equal to P2, which is equal to 90 degrees. Why? Angles on a straight line. Or we can say that CPD is given perpendicular to AB. That was given. Okay? And then PB is a common side. So that is enough to conclude congruency. In what case of congruency is being applied here? If a triangle CPB is congruent to triangle, so CPB, so it must be DPB. Okay, why? What case of congruency is this? Side angle side. Although we're using 90 degrees, we haven't used the hypotenuse to say RHS, which is the right hand hypotenuse side. Okay. So those two triangles are congruent. Therefore, angle B1 is equal to angle B2, which is equal to X. Why? Because of triangle CPB being congruent to triangle DPB. Okay, so there we have an X here as well. Let's look at B. Again, I'm trying to get the diagram in focus. You'll see me erase that all the time. Angle E2 and angle E is equal to 2x. But angle E is the same as angle the combination of angle B1 and 2. Not so. Why? It's angles in the same segment. So E2 is equal to X. Angle E2 is equal to 2X. Why? Because it's angled in the same segment. And it's coming from arc CD. So there's 2X. Then it says hence COF is a cyclic chord. So COF E is a cyclic chord. Now to prove cyclic chords there's many ways of it. Okay? Not many ways, 3 ways. Exterior angle is equal to the interior opposite, the one I'm going to use here. And equal angles are thin by the same chord. And the third one is going to be equal angles are, no, the opposite angles are supplementary. So, as you can see here, that angles are already marked as 2x. If I can prove that O1 is 2x, I've done the job. Not so? But is O1 not equal to 2x? Why? Angular center is twice angular circumference. Can you see that, people? So let's go with that. We say firstly O1 is equal to 2x. Angle at center is equal to 2 times angle at equals 2 times angle at. Okay, so there's 2x. We state the obvious. Since O1 is equal to angle E, which is equal to 2x, therefore CEFO is a cyclic chord. Why? Because the exterior angle equals the interior opposite. Okay. Remember, you are proving it's a cyclic chord, so in our reason we cannot use cyclic chord unless we use converse. Okay. The next one, question 6. We are told that B and Q, BQ and QC are tangents to the circle at B and C respectively. Respectively means to say that QB is with B and OQC is with C, which in other words in that order. If those are tangents, what do we know? We know that that line is equal to that line, which is resulting in that angle being equal to that angle, and so on and so on. Then it's tangents as well. So then B1 has to be equal to angle C3, tan co-theorem. Or that angle is equal to that angle. Okay? And of course equal to that angle. And tangent, so this one there is equal to that one, and so on and so on and so on. Okay? So I'm just going to keep one marking here. Is that there? With this. And that. With that. Okay, 2 markers. Oh, right, let's put that line through. Okay. Then we are told that chord BA and DC are parallel. So if lines are parallel, alternate angles are equal. So that angle is also equal. You see that, people? Alternate angles are equal, or corresponding angles are also equal. Those angles are also equal. D1 is equal to the combination of B2 and D. Corresponding angles and co-interior angles are also even. Okay? I'm just going to leave one marking here. Then chord BD and AC both produce meet at P. PC is drawn. Let C5 be X. C5 be X. Right. First question. Show that C5 is equal to C3. As you can see, shukran. Right, so C5 you must prove, so even in other words, if we can prove that C3 is X, we've done the job. Not so? Right. So looking at this here, which other angle is equal to X? Huh? B3. B3 is XY? Tan co-theorem. Can you see that? The tan co-theorem. So the dots is now X, no? So we're going to say that B3 is equal to x, tan cotheorem. Right. Then C3 is xy, alternate angles, with DC being parallel to BA. Not so? So therefore, C3 is equal to C5, which is equal to x. So there we've done that job. No? Right, let's go with B. C1 is equal to B1. But we already established that C1 would have also been x. Did I say that already? No. But C1 is equal to x. Why is C1 equal to x? Vertically opposite, yes. Vertically opposite angles. Okay? So if we can prove that B1 is x, then the job is done. But hang on, B1 is x. Why? Tan cotheorem. Okay. So B1 is equal to x, tan cotheorem. Therefore, B1 is equal to angle C1, which is equal to x. There, that's also done. Okay. Then the question says, C says, points Q, P, C and B are concyclic. What does that mean? That means to say a circle can be drawn through those points. You understand? So you got Q, P, C, B. Now to prove something is cyclic, a cyclic what? We'll prove one of three things. Firstly, opposite angle supplementary, exterior angle is equal to interior opposite, or equal angles are tended by the same chord. But if you look here, aren't there already angles that are equal using that theorem? Not so? So, since angle C1 is equal to angle B1, which is equal to x, therefore QPCB is a cyclic chord. Why? Why, people? Equal angles subtended by the same chord. Okay? Or arc, whatever. Okay? Do you guys understand? Yes? Sorry? Two points. Yes? 2 points subtended equal angles. 2 points subtending equal angles. Yes, that's fine. I will give it to you. Nice. Okay. Question 8. In question 8 we are told that PC is a diameter. If PC is a diameter, what do we know? That angle B2 and 3 is 90, or angle A3 and 4 is 90. Then we are told chords PC and PA produce meets at E and T respectively, such that TE is perpendicular to PE. So if these lines are perpendicular, what do we know? It's 90 degrees. I say, hang on. Here's 90. And there's 90. So what do we see there? Cyclic what? Not so? Then Is this not a straight line? We are told that B, C, T is a straight. A is actually a straight line. It doesn't look straight, no? Or is it my eyes? Eyes are not straight. It doesn't look straight here. Okay, now you see, I don't feel so bad now. But since it's telling us a straight line, we must treat it as a straight line. Okay. Then we told that CA and AE are drawn. Prove that. ETAC. 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 Oh my word. Exterior angle equal to interior opposite. Who's asking this question? This is an easy question. Okay, so let's go. So firstly we're going to say that, so we take out the Mickey Mouse that we're busy with, right? So we say that, make it official, no? Make the relationship official. CAP is equal to 90 degrees. Why? Angle in semicircle. Right? Now everybody knows about it, you see? Now what do we say? Since it's a given fact that CAP, a proven fact that CAP is equal to TEP equal to 90. Therefore, CE, CAP, ECAP is a cyclic quad. Why? Because the exterior angle equals the interior opposite. There we go. Huh? ECAT. ECAT. Wait, I make another mistake.
No, so for the second line, can you say
For B now. Are you talking about B?
No,
Since, yes, CAP, just hang on. CAP is equal to TEC. Yes, what do you say?
Yeah, I'm just asking if it's the same.
So you're asking if TEP is the same as PET?
No, TEC.
TEC. Yeah! It's the self lane. The same line. Okay. You some Afrikaans lessons here, no? I think I need more Afrikaans lessons than you guys. Okay. Let's go with B. You must prove that C. Now you must remember in that triangle, in that quad, all cyclic quadrilateral properties are evident there. Okay. Now they're talking about ETPB. ETPB, the big one. But we already said that was 90 and there we go angles in your bow tie there. Not so? You all agree with that?
Yes, sir.
Right, so let's go with that quickly. A different rule of what's the name that they're using there, no? Of cyclic quad. So it's going to be CBP is equal to 90 degrees. Why? Angle in semicircle. So we say since TEP is equal to CBP, which is equal to 90 degrees. Therefore, ETPB is a cyclic quad. Why? Equal angles subtended by same chord. Okay? So that means to say that all cyclic properties are evident in that quad as well. Okay, I'm not going to draw circles over circles here. Let's go with the last one. And C, we must prove that B1 is equal to B2. Okay, so B1 is equal to which angle? B1 is equal to P1. Why? Angles in the same, nice. Angles in the same segment. Can you see that, people? Remember, that's a cyclic quad. Not so? Right, now what? P1 is equal to angle B2, why? Angles in this. Oh, what's wrong with you guys? Not so. And therefore B1 is equal to B2. I'm not going to bring out x in it yet. Alright, so we're far in this chapter already. So keep our x out of it, no? So you say B1 is equal to angle P1. Why? Angle in same segment. And this is coming from arc ET. Right. Then we say that P1 is equal to B2. Why? Angle in same segment, and that is coming from arc CA. So if B1 is equal to P1 and P1 is equal to B2, therefore B1 has to be equal to B2. And there we go, proven. Okay, without the x. Which proves, people, we can move on without the x. Not so? Life doesn't stop there, no? We can do it without that, no? Some of you disagreeing with me? Yes? I don't even want to ask who said yes. Just leave it so. Okay, here we go. 13. Number 13. Two circles intersect at A and C. Two circles intersect. Oh, no. Two equal circles intersect at A and C. People, if circles are equal, what do we know? The radii are the same. Right, so if that is the case already, okay, wait, carry on reading. Then you are told that BC is a tangent. BC is a tangent to one circle and a chord of the other circle. So BC is a tangent, so that is going to be C4 is equal to A2. Ne? Right. Then we are told E is a point on circumference of one circle and E, A produced meets the other at D. Chord AE is equal to CD. If that is equal, what do we know? Equal chords, something equal angles. No, equal chords, equal circles, equal angles. No? Remember, that is the one of the corollaries that we did after we looked at angles in the same segment. Okay, it was something like this, right? Where that is equal to that, then that angle is equal to that. Remember, as long as the circles are equal of size. Okay. So that corollary was equal chords, equal angles, and equal something like that. And equal something. Yeah, equal chords, equal circles, certain equal angles. Nice, well done. I forgot about the correct wording. So I would have lost one mark, you see? And AE and CD cut off equal segments of the circle. First question. Prove that C2 is equal to C4. C2 is equal to C4. But if I did, you see this equal chord here is subtending that angle there. That angle and that angle is the same. Not so? Right, so let's go with that. Do you want to bring your x into it? No. Okay, let's move on. So we say, angle C2, we start off with one of the sides. Angle C2 is equal to C4. Why? Tag chord theorem. Okay? But is that going to help us? Yes. C2 is equal to C4. No. C2, sorry. C2, I marked the wrong angle. C2, that is C2. C2 is equal to angle A2. Why E2? Nee, my kind. You see, there's the one circle. That equal chord. It must touch the circumference of the circle to play along. You see, that triangle you're talking about is not touching the circumference of this circle. Nee. Verstaan jy? So, there's your triangle, there's one triangle. That is that angle there. And there's the other triangle.
So that also mentioned it does help us.
It does. I'm going to show you now. You think you say stuff unnecessary? So C2 is equal to, you see from that triangle, C2 is equal to which angle? C2 is equal to A2. You see that? C2 is equal to A2. Why? Say your story there. Equal chords, equal circles, subtends, equal angles. You see here, no? You got this circle. You see that? You see there, no? There's your one circle. And here's your other. And there, there's this angle. Can you see it now? Therefore equal chords, subtend equal angles, equal chords, equal circles, subtend equal angles. Okay? Alright, so we say that one is equal to A2. C2, A2, right. But C4 is equal to, C4 is equal to, people, there's a tangent. E4 is equal to A2. Why? Tan chord here. So, if A2 is equal to C2 and C4 is equal to A2, therefore, C2 is equal to C4. Okay? B, in question B, we are asked to prove that AB is equal to AC. Under what condition would that have been equal? If C1 is equal to angle B. If that was equal, then angle B would have been equal to C1. Now to prove that that is equal, we prove that angle C is equal to B1. Okay? So let's look at C1. C1 is equal to which angle? Angle D is. Why? Tan chord theorem. Okay? Then angle A1 is equal to A1, people. Anybody? Yeah, I'm missing something here. Okay, there's a cyclic chord. Here's a cyclic chord. Okay, that's not going to help us. Let's check what the answers say. Yes?
Angle B
The angle B, yes?
equals C2.
Angle B is equal to C to Y. Angle B is equal to C2. Is that right, people? Can angle B be C2? That's not tan code. Let me see, bring it. Let me see. Something I'm missing here. Did I do that? Okay. So we are told that angle B is equal to angle D. Angle B is equal to angle D. Angle B is equal to angle D. Equal angles subtended by the same chord. Angle B. Yes? Oh, I see. Thank you. You see here, this line called AC gives off or subtends angle B, and that same line subtends angle D. Since it's equal circles subtending angles in the major segment or in the major arc, because that is the case, that angles has to be equal. Okay, so here we go. So you're going to say that angle B is equal to angle D. Why? What's the reasoning? Equal angles subtended by same chord. There we go. Thank you. Then we say that angle D is equal to C1. Not so? Angle D is equal to angle C1. Why? Because tan chord theorem. Right. Now we can say since angle B is equal to angle C1, proven. Therefore, BAB is equal to AC. Why? What's your reason here? Sides opposite equal angles. There we go. This was a good one. No? I would have lost 3 marks or 2 marks then. Okay. Do you guys understand? Thank you. No? Alright, let's carry on with our lives. That's the end of it. Yeah, geometry is at the end now. But at least now, listen. If I'm you guys and you're liking geometry and enjoying it, okay? If you are one of those students, okay? Who think they are on top of geometry now? Nobody? Sorry? You don't like? Okay, now you see, I thought you guys are of those girls that, you know, I must have a positive thought of you guys. Alright? But listen, if you are struggling with geometry now, or you don't like it, whatever, if I'm you, I would now go from 9.1 again. do every exercise and watch every video. So you first do the exercise, then you watch the video. Then you do the exercise, then you watch the video, and so on. Go through it. There's only not many lessons on this. I think it's like 12 lessons or something. No? I don't know how many. Let's check. Can't be 8. 16. Yo. So there we go. This is lesson 17. It feels like only like 12 or something. But okay, whatever it is, okay. Go through it like that. We spent a lot of time on this. 16 lessons is a long time. No? 17 lessons. Go for it. I'm talking and you people are having your own conversation at the back. Your mother's meeting. Would you like to come sit in front? You can't see from the front, I'm sure. No? But you're talking at the back. So I'm going to go put you in front where you can't see. Okay? And can't talk. Then you go through these videos and these exercises. I'm sure you will become better at it. Okay? And you will enjoy it. People, this work is nice. No? If you have done that, you let me know. Okay? Then I'll put you on a little program, on a geometry program. So that you can prepare your grade 12 foundation for geometry next year already. Okay? But if your geometry is weak, then it's not going to make sense to delve into grade 12 geometry yet. You understand? But at this point, you have recorded all the grade 12 geometry already. So the geometry you guys can work through already. I give you the textbook and you can run with it already. Okay? So that is the benefit of actually recording these things. Okay? And you'll see in the long run it should benefit you guys. Okay? Also at this point, you are working on a section on your own. No? I think it's stats. Okay, which lesson are you guys on? Did I give you the second lesson yesterday? Huh? You guys have done lesson 1. Right. Then I said you must add now lesson 2 to your work. Did I say that yesterday? Right. So you got a week to do that. Okay. If you have a problem with it, you let me know, you come to me and I'll explain to you what the issues are. Okay. But what you do is you go through the video. The video explains the examples. You do the homework that is given out of that video. Okay? Yes, you had a question. Sorry? Oh, your other class. Okay, basically what we're doing is, because we're moving a bit slower through these topics, okay, we won't be able to finish everything. Okay, so what I've done was, last year I've recorded the statistics chapter already. There are 4 lessons on, how many lessons are there? 4 lessons on stats, no? So I gave the 1 lesson for them to go learn on their own. They must do the homework out of that lesson. Okay? And then they must wait for me to tell them when to carry on to the next one. So yesterday I told them to carry on to the next one. But you guys weren't in the group as yet. No? So you got 2 lessons to do. So can somebody just repost that the Word document I put in the group? For those of you who don't know what I'm talking about, come to me during second break. I explain to you. Bring your tablet with and we'll take it from there. People enjoy the rest of your day. Good morning, class. Yes, Michael.
How and 8?
Your mistake, yes, you see there's a square. From the square you'll never get a negative. So that would have to be positive. So here you would have had sine squared x plus cos squared x. And what's sine squared x plus cos squared x? 1. But that's your mistake.
Because I was wondering, why did I keep on getting negative?
Yeah, that's your mistake.
And then,
Bye. Bye. That's right. That's right. So it's negative. 1, 2, 3. You see there's 3 negatives. How negative times negative is what? Positive.
but so I was confused. I was like, so Okay, so this negative applies to both the sign and the cos.
Yeah.
Because I thought it was just for the denominator.
It's for the whole fraction.
The whole.
Right, you got it? I didn't guess.
So angles subtended by same chord is the same thing as angles in the same segment.
Angles subtended by the same chord. That is the converse. It's the reverse of angles in the same segment.
Oh, okay. Thank you, sir.
No problem, Michael. Yes. Another question.
I just realized
Nope.
something. I wanted to make sure it's okay. So like in this type of situation.
Yeah, it is another thing, the negative lies there. Because this 3 is being multiplied by 10.
Oh, so the negative mustn't come
Between it, no. Don't let signs come between you and you. The coefficient and the...
I was
And
using 7.4. Can you check if it's so far?
Yeah, can't check. You mark it and you bring it to me.
Oh.
Yeah? It's going to take too long for me to check. Can you just bring the problems you have?